Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting at the levels of both CSEC, Form 5 exams, and KEEP, Form 6 exams. In this video, we'll be looking at CSEC Mathematics and the past paper questions on geometric construction. We'll be specifically looking at the questions from May 2009 until May 2013. Feel free to like the video and add any comments down below so we can help you in any areas that you are getting problems with. Don't forget to look at the description down below where we have outlined the entire CSEC Maths syllabus and the order in which we should go through our videos to look at all the past paper questions from May 2009 in every single topic until the present. Let's recall the 10 major topics in CSEC Math, and we'll be focusing in this video on the 8th topic, Geometry and Trigonometry. This topic number 8 comes for 8 questions in the multiple choice, which is 8 out of 60 in paper 1. And 21 marks out of 100 in paper 2. Topic number 8 can be split into 2 parts, into trigonometry and geometry. And we'll be looking at geometry, which can be subdivided into 4 further parts. 1, geometric construction, which is what this video is about, unknown angles, circle geometry, and transformation. In this video, we looked at past paper questions from 2009 until 2013, and each of the 5 years, a question on geometric construction was tested. The main skills that students are required to show in geometric construction includes constructing angles using a pair of compasses, a ruler, and a pencil, and making the following 5 angles. Making a 60-degree angle, constructing a 30-degree angle, and we'll be doing that using a 0 and 60 degrees, constructing a 120-degree angle, and we'll be doing such using a 60-degree angle, constructing a perpendicular or right angle or 90-degree angle, and there are many ways to do this. We'll be using the 60 and 120 in order to create the 90-degree angle. And constructing a 45-degree angle, we'll be doing so by bisecting the 0 and 90-degree angles. They're also expected to be able to construct a perpendicular bisector of a line. This means that they need to construct a line which cuts the original line in half at a 90-degree angle. Also, they need to be able to construct a perpendicular to a line from a point. And they'll be able to construct parallel lines. So the general steps when working out this question would be, first of all, to draw a sketch of the information given. And then second would be to draw the baseline and solve with particular construction is required. May 2009, number 3b. The diagram below, not drawn to scale, shows a rhombus PQRS with the diagonal PR is equal to 6 centimeters and the angle RPQ equals to 60 degrees. So let's recall what a rhombus is. A rhombus is basically a square in the concept that all 4 sides are equal and it is pushed sideways. So the angles at the corners are not 90 degrees. So if we consider that, then we can see that PQ, the length of it is equal to QR, which is equal to RS, which is equal to PS. So part 1, using a ruler, a pencil, and a pair of compasses, construct the rhombus PQRS accurately. So let's consider the solution that if it's a rhombus, we know the sides are the same. And if PQ and QR are the same lengths, then that top triangle PQR is an isosceles triangle. But if the angle at P, which means RPQ, that angle is 60 degrees, then the angle at the other side of the base, which is PRQ, will also be 60 degrees. And if we have two angles in a triangle being 60 and 60, then the third angle must be 60 degrees as well, because all three angles add up to 180 degrees. So if we have a triangle where all the angles are the same, then all the sides are the same. So triangle PQR is an equilateral triangle, and similarly the triangle below, triangle PSR, is also an equilateral triangle. Since we know this, then there are many different ways we can use geometric construction to solve this question. So I'll try to use the simplest way that I see my students can understand. So the first step, draw a long baseline, which we have in red. Step 2, construct the line PR. So let's look at our sketch above. We're using our sketch to give us a guide how we are going to draw this diagram accurately. So how do we construct this line PR? By placing the point of the compass on P, and P will be anywhere inside the edge, not on the edge but a little closer. So our long baseline must be longer than 6 centimeters. So we put our compass there and we draw an arc, which we have in blue, and we label the point on the right side as R, trying to follow our sketch above. Now part 3, draw an arc of 6 centimeters with the point of the compass on R for QR. So that will give us the other arc, also in blue on the left hand side, and we label the point where the arc meets the red line, the baseline, as P. So we have PR, and that is 6 centimeters. You can double check it with your ruler now. And where does the arcs intersect? They intersect at Q, so we can label that. So we've gotten the points P, Q, and R. Let's repeat the exact method for the lower triangle, for triangle PRS. And after we've drawn the arcs, we've labeled S. Now we complete the rhombus by drawing the line through PQ, QR, and so on. And we're not drawing the exact points, but we're drawing a longer line. Remember, the concept of geometric construction comes from technical drawing, where it is that we're showing the actual points as points of intersection. So we don't start at P, but we start below P and make the line longer than PQ. And we make the line longer than QR, and the points where they intersect will be those points. So you can double check it and you will find that all four sides, the angles, the lengths are the same, 6 centimeters, and the angles are 60 degrees throughout in each of the triangles. Part 2, join QS and measure and state in centimeters the length of QS. So if we draw a line from Q to S and then we measure it, we will get QS length. May 2010, number 4B, Part 1. Using a ruler, a pencil, and the PF compasses, construct a triangle EFG with EG equal to 6 centimeters, angle FEG equal to 60 degrees, and angle FGE equal to 90 degrees. Now let's make a sketch, and we will put on the base EG because that's the length of the side that we know, 6 cm. We know the angle at FEG, which means the angle in the middle letter. The angle at E is equal to 60 degrees. That's on the right hand side of our sketch. And angle G, which is on the base on the left hand side, is 90 degrees. So they're really asking us to construct a right angle triangle. Now let's recall that there are many ways to construct the angles correctly using the pair of compasses. So I'm using a method which I've found my students to get least problems with. So the first step will be to draw a long baseline, longer than 6 centimeters, and then we put our compass somewhere, not on the end, a little bit on the inside, and we scribe an arc that will give us E, and we turn our compass around. The compass, of course, being of the length 6 centimeters, and we scribe an arc, and that will give us G. So we have the baseline EG is equal to 6 centimeters. And this is only possible if we accurately open our compass to exactly 6 centimeters by placing our compass on a ruler and making sure our compass is tight so that when we're constructing our arcs, it does not move. Now let's construct the 90 degrees angle at G. So in order to construct a 90-degree angle, what we do, and there are a few methods for this, we rest our compass at G to any arc length, anything that's comfortable. So I've reduced it a little bit. It doesn't matter what the length is. And I'm scribing an arc from G, making a large arc across. And really, when we make an arc like this, it's sort of reproducing a protractor. So we can see on the right hand side where 0 degrees is. So we rest our compass at 0 and we scribe an arc which is of the same length. And you can see that that gives us 60 degrees. And now we go to 60 degrees and we scribe another arc which will give us 60 and 60, 120 degrees. And if we consider 90 degrees is in the middle of 60 and 120, so we have already scribed an arc with 60, so we now come on 120 and scribe another arc. And where they intersect, we can draw a line straight through that from G straight upwards, and that will be giving us our line on the left hand side. So according to our sketch, we've gotten two lines already. We've gotten the baseline and the line on the left, which is 90 degrees, the perpendicular line. Now we just need to construct a 60-degree angle at E. So we rest our compass, our metal point of the compass on E to any length, and we scribe an arc. If we scribe an arc again, that will be like creating our protractor. That's the 0 line. We rest our compass on the 0 line now and we scribe an arc, and that intersection is 60 degrees. So we draw a line through E, through the intersection, and continue it until it intersects the perpendicular line or the vertical line. And where they intersect will be F. Part 2. Measure and state, Part A, the length of EF. So if we measure EF, that should give us 12 centimeters. However, the marking system is such that we know some students differ slightly. So anything 0.1 centimeters above 12 or below 12, plus or minus 12, will also be given a mark. So if you got 12 centimeters, 12.1, or 11.9, anywhere within that range, that will be fine. And part B, the size of the angle EFG. And if the base angles are 60 and 90, that angle up on top, EFG. Remember EFG, if we have an angle like that, it means the angle is in the middle letter at angle F. So the angle there will be 30 degrees. And they've given a little range, 30 plus or minus 1 degree. So 31 degrees or 29 degrees, anywhere within there will also work. So we've constructed the right angle triangle. May 2011, number 3B, part 1. Using a ruler, a pencil, a pair of compasses, and a protractor, draw accurately a quadrilateral EFGH using the following measurements. EF is equal to 8 centimeters, angle EFG equal to 125 degrees, FG equal to 4 centimeters, angle HEF equal to 70 degrees, and EH equal to 7 centimeters. Now, no sketch of this diagram was given, so let's see if we can make one for ourselves. If we look at the lengths of these sides that were given, we can see EF is equal to 8 centimeters. That was the longest side. So we can use that as our sketch. This sketch that we're making is freehand. It's just to give us an idea of the general outlook of what this construction is going to look like. So EF is on the base, and the angle EFG is equal to 125 degrees, which means that it is more than a right angle. Remember, if it's the angle EFG, it means we're starting from E and we're heading to F, that's one line, and then we're turning 125 degrees, so that means we're turning, in this case, we can turn clockwise at the corner of F, and that will give us a FG, and then we know FG is 4 cm long, and we're just making a sketch to this. It's on average. And then angle HEF, that angle will be at the middle letter, which is E. And we can figure that out also by saying we're drawing a red line from F to E, and then turning it to go up E to H. So that will give us 70 degrees there at that corner. So remember that if we're given an angle, it's the middle letter of the three. It's where the angle is located. And H is 7 centimeters. So let's look at the steps. First step, construct the baseline EF, which is 8 centimeters. So what do? We draw a long baseline, which we have in maroon, which is longer than 8 centimeters. And we rest our compass on the line, not on the edge, but a little on the inside, and we scribe or mark an arc, and that will give us F. And then we turn the compass around and rest it at F, the metal point, and we scribe an arc to give us E. So we have EF. Remember, each point is an intersection of lines. So we can see where the blue mark intersects with the maroon on these 2 points to give us the base EF. Step 2. Place a protractor with center on E. Measure the angle HEF, which is 70 degrees, and we can do either side. We can do the left side or the right side. So I'm just choosing to do the left side first. So why is it that we're using a protractor? Because, as we recall when we summarized the topic earlier on, the angles that we are required to make in geometry are 30 degrees, 45, 60, 90, and 120. So 70 is not one of those, so we'll have to use our protractor. So we place our protractor on E, make sure that the center lines up directly on E, and that the baseline, the 0 to 180 degrees, is directly on the red baseline of EF. So we're starting on the right hand side with the 0 there, and we're going up 10, 20, 30, 40. That's the outside scale until we reach 70 degrees. And now that we found 70, we place a mark there, or a dot. We can remove the protractor and we draw a line from E, longer than E, through E and the point. That's a blue line. Now we know how long EH is. EH is 7 centimeters, so we open our compass to 7 cm, rest it on E and scribe an arc. And where they intersect, that point is H. So we found 3 of the points. We just need the last point. So how do we get G? Well, we know the angle on the right side base is 125 degrees. So that's not an angle that we can construct. So we rest our protractor. On the same method as we did at E, we're going to rest it at F, because that is where the angle is being made. And when we place our protractor there with the center on F, let's measure 125 degrees. In this case, we're starting from E going to F. That's the baseline on the left. So we're using the 0 on the left side, which will be the inside scale, not the outside. And we go clockwise 0, 10, 20 up to 125. We place a mark there or a dot, remove the protractor, and let's draw a long line passing through F and the mark. And now we just need to find where G lies. We know G lies somewhere along that blue line, and FG is 4 centimeters. So let's open our protractor to 4 cm, scribe an arc, and then we have all 4 points. We have 3 of the sides already drawn, so let's draw a line through HG to complete the quadrilateral. Part 2 of the question. Measure and state in centimeters the length of GH. And we can just use our ruler and measure that, or put our divider on the points of G and H, and then rest it on the ruler. So GH works out to be 8.5 centimeters, and we're given a little play, so plus or minus 0.1 centimeter. May 12, number 5A, part 1. Using a ruler, a pencil, and a pair of compasses, construct triangle PQR with PQ equal to 8 centimeters, angle PQR equal to 60 degrees, and angle QPR equal to 45 degrees. Now, we're not giving any sketch, so let's make one. We have one length, the line PQ, so let's use that as our base. PQ is equal to 8 centimeters, and the angle PQR, which means the angle, look at the middle letter, Q, is 60 degrees. That's on the right hand side. And angle QPR, which means the middle letter, the angle at P, that's 45 degrees. So we need to make a 60 on the right side and a 45 on the left side after we've made the baseline. So steps. First step. Construct the baseline PQ equal to 8 centimeters. And as usual, we draw a long baseline, which we have in maroon, more than 8 centimeters, anything longer. Then we rest our compass, we open it to 8 centimeters, and we rest it a little inside, not on the edge, and we scribe an arc, and that intersection, that with the blue mark and the maroon line gives us Q. We turn around our compass, so we rest it on Q now, the metal point. We scribe an arc, and that will give us P. So we've gotten the baseline PQ because it's shown by intersections of the 2 points. Now we need to make the 45 degrees. So let's construct a 45 degree at angle P on the left hand side and draw a line through it. So how do we do that? Well, we need to get a 45, we need a 90. To get a 90, we need a 60 and a 120. And now there are other methods as well, but I try to stick with this standard one. So first thing to do, scribe a long arc where we open our compass to any length, rest it on P, the metal point, and scribe a long arc looking like we're making a protractor. So we'd have where 0 degrees is on a protractor on the right hand side, and then rest our, without adjusting the length of it, make sure that remains the same. That's the key thing in this question. Rest the metal point on 0 and scribe an arc, that will give us 60. Then shift the compass up to that point at 60 and scribe an arc, a long arc, which is 120 degrees. So we got 0, 60, 120. If we have 120, we know 90 is between 60 and 120, exactly halfway. So we go to 120 and scribe an arc, and that intersection shows us we can draw a line straight through it, and that will give us 90 degrees. Now many students make a mistake here where they already have the 0, right, an arc for that, and 90. So 45 is directly between 0 and 90. Their mistake is that they usually put it where 90 has intersected, up on top. However, after you've drawn the base protractor line that we have in this blue arc where we wrote 0, 60, 90, 120, our metal point always lies somewhere along that line. So we rest our metal point on 90 degrees and we scribe an arc intersecting the first one. So we have it directly between 0 and 90. That is, we can draw a line straight through it through that intersection and P, and that gives us the 45-degree angle. Now, on step 3, let's construct a 60-degree angle at Q and draw a line through it, intersecting it and giving us giving us R. So at Q, doesn't matter what length of compass you have, just whatever you pick, don't change it. So we rest our metal point on Q, scribe an arc from below the baseline, going upwards. So we know we're making another protractor, and we know where the 0 degrees is on the left hand side, kind of like in the middle of it, of the PQ line. We rest our metal point on that, and we scribe our arc where it cuts, and that's 60 degrees, that intersection. So we draw a line from Q through the intersection up, and where these two black lines intersect, that will be R. So part 2 of the question, measure and state the length of RQ. And we just use our ruler. May 2013, number 4A. The diagram below shows an isosceles triangle CDE. And if we look at the triangle, we can recognize that the angles at C and D are the same, and the length of the sides CE and DE are also the same. The question goes on, G is the midpoint of CD. Part 1. Measure and state in centimeters the length of DE. So, using a divider, we can rest our divider at that point and then place the divider onto the ruler to find the distance DE, which works out to be 4.9 centimeters. Or we can just rest our ruler directly, as the case may be. And in part 2, measure and state in degrees the sides of angle ECD. Now let's recall, if this angle ECD, it means we're looking at the middle letter C, at that angle. Or we can say it is the angle is between two lines, the line EC and the line CD. So using a protractor, let's place the protractor directly on top of C, where the angle 0 degrees on the right hand side lines up with CG. And we can measure the angle, and the angle ECD is equal to 36 degrees. And they allow us a little leeway, so plus or minus 1 degree will work. So if you got 35 or you got 37, that will also work as well. In part 3 of the question, determine the perimeter of the triangle CDE. Let's recall perimeter is the distance around, and if we consider the big triangle CDE, then there are 3 sides. So perimeter just means to add up all the sides. So we can add up CD plus DE plus CE. And we know 2 of those sides already. That's 4.9 each. We just need to measure the base CD, and that is 8.2. So the perimeter of triangle CDE is equal to 8.2 plus 4.9 plus 4.9, which we got in part 1. So the perimeter works out to be 18 centimeters, plus or minus 0.3 centimeters. And in part 4, calculate the area of the triangle CDE. So if we want to use the area, we can use the information from before to help us. Remember that if we look in our formula sheet, we can see the area of a triangle is equal to half AB sine C. So area of a triangle CDE is equal to half. What's the 2 sides? We'll be using EC and the CD, sine the angle in between ECD, which we already know from part 2. So let's substitute. Area of triangle is equal to half times 8.2 times 4.9 times sine 36 degrees. And make sure our calculator is set in the degrees mode and hasn't moved to radians or grad. And that works out, using our calculator, the area of the triangle to be 12 centimeters squared. We've now come to the end of the CSEC past paper questions in the topic of geometry, specifically geometric construction. We've completed the video on May 2009 until 2013 past paper solutions, and our next video will be on past paper solutions from May 2014 until 2018. Feel free to look at the description down below so you can follow the order we recommend for going through all these past paper questions with their solutions from May 2009 until the present, so you can get a better understanding of the syllabus and, of course, get a better grade.